Yes.
All right. So number 7, you have your 2 segments. What kind of segments are they?
Is that like the secant segment and then the tangent? Is that what it is?
Actually, number 7 is 2 secants because it has on each piece, there's 2 numbers. So you have 2 parts of each piece. If it's a tangent, there'll just be 1 part on one of the pieces.
Okay.
So, when you have 2 secants, it's the whole times the outside equals the whole times the outside.
Okay.
So what would you do to set up that equation? For the top one, what would you have?
Okay. So 12 times 5 equals x times 4 plus x.
You got it.
Okay. So then it would be 60 equals 4x plus x squared.
So then it's one of those where there's an x term and an x squared term. So you know there's 2 possible answers. So you have to either do factoring or quadratic. But because it seemed like most didn't remember either, we're just going to stick with quadratic because it always works.
Okay.
Factoring just sometimes works. So you have to know if it will work. So in this one, you get everything together on one side. And I would move everything to the right side to keep this x squared so that it's positive, not a negative number.
Okay.
So x squared in the front, then 4x. Then it's going to be minus 60 because you're moving it to the other side. Does that make sense?
Yes.
Okay. So then you have quadratic formula. Let me white out some of this other stuff so I'll have some more room. Oh. It's not a perfect system, but it works okay. All right. So quadratic formula is negative b plus or minus square root b squared to b, sorry, b squared minus 4ac over 2a. Sorry, that b's kind of goofy there in the middle. But that's the formula. So then you need to figure out what is a, b, and c. In the equation we have on the right side, what's a?
60?
Mm-mm.
Oh, no. I don't know.
It's okay. I won't. That's why I was asking. I want to know how much you know because I don't want to tell you if you already know. The number in front of the x squared term is going to be your a.
Oh, okay.
So for this problem, it doesn't have a number. So you remember there's an understood 1 always. That's a. B is going to be the number in front of your x term, and you use the sign with it also.
Okay.
That's B. And negative 60 is C. C is always your constant also. Whatever is just a number with no variable. So if that helps you remember C for constant.
Okay.
So then you plug those numbers into the formula. So you'd have opposite of B, which would be, I'm going to do it kind of in between. Using other colors so everything will be blending together. All right, the opposite of B, negative 4 plus and minus square root b squared. So what would that be?
So wait. Oh, 16.
Minus 4 is just part of the formula. And then A, how much is A?
1.
And C.
Negative 60.
on just the top part of the equation? Do you understand where all those numbers came from?
Yes.
Okay. So then the denominator is 2 times a, which is just,
It'd just be 2.
it stays 2. I just put the 1 so you remember. Sometimes if there is a number in front of x squared, you'll have to multiply that.
Okay.
All right, so then order of operations, you need to do everything under the radical first. So keep that -4 out front, plus, minus. The 16, you can't do anything with it yet because some other things are multiplied. So all this stuff is multiplied together. So it's -4 times 1 times -60. How much is that?
-4 times, times 1 times 240.
And it's positive, so we're going to put plus 240. Because that -4 there, that makes the -4, so negative and negative positive. Are you okay with the red part, where that came from?
Yes.
Okay. Over 2, because just 2 times 1. All right, we still have some things under the radical you can combine, so do that before you use that -4 in the front. -4 plus and minus. This is 256.
Yes.
Alrighty. Over 2. Do you know the square root of 256 without your calculator?
Is it? No, I don't.
It's a good one to memorize if you haven't. It's 16. The square root of 256 is 16. So now we have 2 problems. We have, well, let me not do that step yet. Hang on, let me go back. -4 plus and minus 16 over 2, because that's the square root of 256. That's where the 16 came from. Put a little line because that's kind of squishing together. Sorry. So now we have 2 problems. We have a plus and a minus. We have -4 plus 16 over 2. And we have -4 minus 16 over 2. So the answer when you add the numerator numbers would be what?
4.
Let's see. 16 minus 4 is 12. 12 over 2, right?
6.
Yeah. 6 would be this answer. And when you subtract them, -20, -10, is that right?
Yes.
Okay, so you have 2 possible answers. And in algebra, you stick with both of them. But in geometry, you look back at the figure, and our x is talking about this length here. And since a length can't be negative, you only keep the positive answer.
Okay. So since you always keep the positive, well, like if you know it's not going to be negative, do you have to do the negative one?
If on your diagram there's just an x, like in number 7 it was just x, then I would say probably that's safe. Okay. If in your diagram, though, I'm just going to change problem number 6 for a second. If in 6, instead of x, if it was x squared right there, then the negative answer would have worked, because when you square a negative, it makes it positive. So if in your diagram there's an x squared, a negative answer will work.
Okay.
It was a long process, but do you have questions about some of the steps along the way?
No, I think I got it. Thank you.
You're welcome. That one, just a side note, when you get in your quadratic to this part, if that part that I just circled in green, the root 256, if that's a perfect square, that tells you that it would have factored.
Okay.
So if we were going to go back and relearn factoring, I would show you that you could solve this one either way. You could do factoring or quadratic, but some problems factoring will not work. So rather than y'all getting frustrated about, oh no, I tried factoring and it didn't work, so now I've got to go through this whole other process, we're just going to do quadratic.
Okay.
Do you have other questions?
Oh, like a question on number 5
Mm-hmm.
is, do you do like, how would you set that up?
All right, let me go back to the other page. Let's see. All right, let me grab that one. All right, can you see it?
Yes.
Okay. This one is two chords that are inside the circle. Nothing's going out of the circle. And they are cutting each other into pieces. So there's 4 pieces there. If that's what your diagram looks like, then it's piece times piece equals piece times piece.
Okay.
So these two go together, and then these two go together. Does that make sense? Kind of.
Yes.
So for the purplish color, you'd have 6 times 8. And then for the green, you'd have x times x plus 8.
Okay.
This one, you're going to have an x squared term and an x term again. So you're going to need quadratic again.
Okay.
Do you want to do it together?
Yes.
Okay. So getting there is not so bad. 6 times 8, 48. And then what do you get on the right side?
X squared plus 8x.
Mm-hmm. So then you get everything. I would move it to the right side. The reason I'm moving it to the right is because the a part, the number in front of x squared, I want to try to keep that positive if I can. It just is a kind of a common practice to try to keep that positive.
Okay.
We like to stay positive, right? So 0 equals x squared plus 8x. And then move the 48 to the other side, makes it a negative 48.
Okay.
This one will also factor, but quadratic will always work.
Okay.
So we need A, B, and C. What's A?
1,
Mm-hmm.
and B is 8, and C is negative 48.
You got it. And then just, I'll put the formula down here as a reminder. Negative B plus and minus square root B squared minus 4AC over 2A. Do you want to work it on your paper and not look at the screen? And I'll work it on the screen and then you can check?
Yes.
All right, let's try that. So I'm going to keep going on the screen, but I won't talk out loud while I'm doing it, okay?
Okay.
You doing okay?
Yes.
Good.
I got 4.
You got it right. Very good. Questions about that one?
No, I think I'm good. It's just like I think setting it up, like just knowing when to do quadratic.
Gotcha. If there is any time, well, the setup has to do with what the pieces are in the circle. Like number 7 was different from 5. It depends on what the pieces are about what you multiply together, or if you have to square things when there's a tangent, that sort of stuff.
Okay.
That's this part right here. The picture tells you that part.
Okay.
When you know to use the quadratic is if you have, and these colors just blend together. If you have an x squared term and an x term, both that won't go away, because we've had problems where x squared cancels out or all the x's cancel out or something like that. But if you can't cancel them out at all, then you need quadratic.
Okay.
Next year, you'll do more factoring as well. So you'll get a review of that and do more of that next year.
Okay.
All right. I'll stay on if you have other questions or anything. You can ask. I'll be on till 10:30, so but I'll probably mute it because my little guy's watching a movie. So
Okay. Thank you.
you're welcome.
Miss Wynn, for number 10, how would you set that up?
Sorry, I heard you, but I'd stepped in the kitchen. Let me get the problem real quick. Number 10, you said, right?
Yes.
Okay. All right, that one is a tangent and a secant.
Okay.
So the secant, you do the same way with the outside times the whole thing. The tangent, sorry, I'm trying to get it to pull up. The tangent, there's nothing to multiply it with. So you multiply it with itself.
Okay.
It's there. Okay, can you see it now?
Yes.
Okay. So get rid of some of this stuff. Come on. Oh boy, I erased too much. There we go. Went a little crazy with my eraser. So it'd just be 24 squared for that tangent piece because there's nothing else to multiply with it.
Okay.
So 24 squared would be that one side of the equation. What would the secant part of the equation look like?
12 times x, or 12x.
Not quite. 12 times. What's the whole piece?
Would it be 12 plus x or 12x?
Yeah, there you go. 12 plus x.
Okay.
Because remember, x is like a number. So if x was, I don't know, 20, you'd say, oh, that piece is 32 because you're adding those two numbers together. So when you're trying to get the whole length, you add it together. So 24 squared. Can you go from there, or do you want me to work it with you?
I can do it from here. Yes.
Okay. Let me know if you have a question, and I'll do it on the screen, and you can check it when you're done.
Okay. Okay. I got 36 too. So
Very good.
thank you.
You're welcome. Yeah, that one you didn't have to use quadratic because it didn't have the squared and the x term. It just had an x.